Have you ever wondered how satellites work, silently orbiting miles above our heads? As we go about our daily lives, these celestial workhorses whisper down data, guiding our GPS, powering our communications, and watching our weather. The complex world of satellites might seem like rocket science, and well, it is. But don't worry, we're here to unravel the mystery. These technological marvels are more prevalent in our lives than you might think. Stay tuned as we journey through the life cycle of a satellite from launch to operation. The satellite's journey begins with a rocket launch, a spectacle of power and precision. This is no ordinary journey. The rocket serves as a reliable taxi, tasked with the critical mission of carrying the satellite beyond Earth's atmosphere. From the ground to the boundless expanse of space, the stakes are incredibly high. Think of the rocket as a multi-stage vessel. Each stage has a specific role, propelling the satellite farther and faster with the ultimate goal of achieving escape velocity. That's the speed needed to break free from Earth's gravitational pull. It's a massive challenge, but one that's been mastered through years of scientific advancement and technological innovation. But launching is just half the battle. Once the satellite reaches space, it must be accurately positioned. This is crucial for its functionality and mission success. After all, in the vastness of space, location is everything. Once in space, the satellite is ready to begin its work, but first it needs to find its place in the cosmos. In the vastness of space, each satellite has a specific spot to call home. Now let's delve into the concept of orbits. An orbit is essentially the path a satellite follows around a planet. This is not a random pick, but a meticulously calculated trajectory. There are mainly two types of orbits, geostationary and polar. A geostationary orbit allows a satellite to stay fixed over one longitude, making it seem stationary to an observer on Earth. This is ideal for communication or weather satellites that need a constant line of sight with a specific area. On the other hand, a polar orbit takes the satellite over the poles, allowing it to scan the entire planet as it rotates beneath. This is perfect for Earth observation satellites, mapping and surveillance missions. So you see, the satellite's mission significantly determines its positioning in space. Each satellite's orbit is a strategic decision, tailored to its unique purpose. Once in its orbit, the satellite is ready to begin its main operations. In orbit, the satellite begins its work, whether that's weather monitoring, communication, or scientific research. Satellites are like the diligent workers of space. They carry out a variety of functions depending on their design and mission. Some are like cosmic weathermen, keeping a vigilant eye on Earth's atmosphere, predicting weather patterns and helping us prepare for severe weather events. Others act as celestial communicators, relaying signals around the globe and making our world a more connected place. These satellites communicate with Earth through radio waves. Just like a walkie-talkie, they send and receive signals from ground stations, enabling us to watch our favorite television shows, navigate our way using GPS, or even communicate with astronauts aboard the International Space Station. Powering these operations is the sun. Satellites are equipped with solar panels that convert sunlight into electricity. This energy powers the satellite's systems and instruments, ensuring they can perform their duties without interruption. You could say that these satellites are quite the environmentalists, harnessing clean, renewable energy even in the depths of space. However, operating in space is not without its challenges. Satellites have to contend with harsh radiation from the sun and cosmic rays. This radiation can damage their electronic systems, reducing their operational life. To combat this, satellites are equipped with shielding and robust electronic systems to withstand this harsh environment. And let's not forget about space debris. The remnants of old satellites, spent rocket stages and other fragments pose a threat to operational satellites. Imagine trying to work while dodging bullets. Satellites are designed to track and avoid these pieces of debris, ensuring they can continue their operations unimpeded. Despite these obstacles, satellites persevere, fulfilling their missions and providing us with invaluable data and services. Whether it's helping us understand our changing climate, exploring distant celestial bodies, or enabling global communication, satellites are essential to our modern world. The satellite continues its operations until it is no longer functional or its mission is complete. And even then, they continue to inspire us, silent sentinels reminding us of our technological achievements and our quest to understand the universe. Like all good things, a satellite's mission must eventually come to an end. The final chapter in a satellite's life is as crucial as its launch and operation. When a satellite nears the end of its functional life, teams on the ground have to make important decisions. These decisions revolve around how to decommission the satellite safely, ensuring that it doesn't pose a threat to other operational satellites or contribute to the growing problem of space debris. There are a couple of methods commonly used. One is to move the satellite into a graveyard orbit, a place where it can rest undisturbed and out of the way. The other is to direct it back to Earth, where it will burn up upon re-entry into our atmosphere. Decommissioning a satellite is a delicate process, a final ballet in the vastness of space. Even after its mission ends, the satellite's legacy continues, contributing to our understanding of the universe and our place within it. Satellites, these marvels of technology, play a crucial role in our day-to-day lives. We've journeyed together through the life of a satellite, from its humble beginnings on Earth to its final resting place in the cosmos. We started with the probing of the unknown, where we explored the purpose and design of these incredible machines. Then, we witnessed the thrill of liftoff, as our satellite was propelled out of our atmosphere and into the vast expanse of space. Once in orbit, we delved into the complexities of positioning in space. We learned that satellites don't simply float aimlessly, but follow precise paths, governed by intricate calculations and the laws of physics. Then, we walked through the operational life of a satellite, understanding the multitude of tasks it performs, from weather forecasting and GPS navigation to scientific research and military surveillance. Finally, we touched upon the end of a satellite's mission, when it either burns up in Earth's atmosphere or is relegated to a graveyard orbit. It's here we see the cyclical nature of a satellite's existence, from creation to destruction, and ultimately, rebirth in the form of new technology. So the next time you look up at the sky, remember the silent sentinels orbiting above, and marvel at the human ingenuity they represent. For it is through our curiosity and inventive spirit that we continue to push the boundaries of what's possible in space and beyond.